Hello, welcome back to another video on our series about quadratic functions, and this time we're going to go over graphing a function based on the completing the square strategy. Okay, we've already gone through just the basics of what functions are, quadratic functions and functions in general, and then how you can graph these functions using axis of symmetry and intercepts. Okay, you can check out that video in that series right here. But right now, we're going over another strategy called completing the square, which we use to find the vertex of a certain quadratic function, okay? Which is usually, in some cases, is the quickest way to graph your function, okay? Before we get into that, I just want to get into some important terminology and a formula, okay? Which I didn't go over in the last video because I forgot about that. And these terms will be flying around a lot, so it's very important we have them very clear what they mean. A binomial is some parenthesis, some grouping that has two terms added together. And what is a term? Well, a term is simply something, a group of things that are multiplied. So in this case, this term could be 2, it could be x, it could be 2 times x, it could be x times y times z. And usually you wouldn't even write the multiplication, but for example, these are examples of terms, okay? And so a binomial is a parenthesis that has two terms, right? And second, this is what we call the vertex form formula. It's a way of representing functions just like our standard form ax squared plus bx plus c. This is another way that people usually represent quadratic functions. What we're doing by completing the square is trying to reach this vertex form, because when we get there, it is really easy to find the vertex, and I'm going to show you why in the end, okay? So let's take this example, y equals x squared plus 4x plus 7. First, if we look at this and try to use the normal solving for the intercept strategy, you can see that this quadratic isn't so easily factorizable, because if you were to do sum and products, two numbers that sum to 7 and add up to 4 is not something that you're going to find. It's probably going to be some fractional intercepts. You could use a quadratic formula, go ahead, but this is another strategy that you can use really quick if you know how to use it, okay? So I'm going to break it down into some steps. First, we want to make this part of our quadratic function into a perfect square trinomial. And what is that? Well, first, a trinomial similar to binomial is the exact same thing, but you have three groups, three things that are added together, okay? And what this basically looks like is, well, we want to have some x squared plus something x plus something that equals x plus something squared. For example, let's take an example. Let's say you had x plus 1 squared, right? This is the same thing as x plus 1 times x plus 1, which gives you x squared plus 2x plus 1, yeah? And this, in this case, would be a perfect square trinomial, okay? For another example, you could have x plus 3 squared, which is, again, the two things multiplied by themselves, which is x squared plus 6x plus 9, which, again, this is an example of a perfect square trinomial. And we want to find this so that we can create, instead of this messy quadratic, we can create a binomial squared inside of it. See, we want to get to this inside, okay? And also on a note, I'm considering here that our a term is 1, okay? I'm considering only examples where this is 1, where you have something multiplied to your x squared. Things change a little bit, but I'm going to take the simple examples first, okay? Okay, so let's take our example. We want to, so we already know what's together with x. So let's bring that right here for our example. We know that we have x squared plus 4x. We just want to know this last number here. And how do we do that? Well, there's a conceptual way to find it that has to do with sums and products, but I'm just going to go over a formula that we have, which is b over 2 squared, okay? And this b relates to our standard form equation plus c, okay? Then this is the b term, okay? In this case, that is 4. So, to find this last number that we need to add to create the perfect square trinomial, we need to do this formula. So, since the b is 4, we can take 4 over 2 squared, right? 4 over 2 is 2. 2 squared is 4. So this is the number that we're going to add to create our perfect square trinomial. Okay, first step done. Now we need to do something to this function that won't change the actual function, because remember, we're just rewriting this function in a different way that's more useful. This is not, it's just this function rewritten in a different way, okay? So here we want to rewrite this so that it includes a perfect square. How do you do that? We write, okay, y equals x squared plus 4x, and here we will add and subtract from this side this number that we just got to the formula. So we will add 4 and subtract 4 and keep our plus 7 in the end. And this, as you see, doesn't change the value of this side, because if you were to do normal math, these two would just cancel out and leave you with the original function, right? But this becomes very useful when we come here and group this side of the function together. And this grouping is totally like arbitrary. You could group any part of the function. If you wanted to group this, you could also group this. But this just becomes useful so that we can do what? Factoring. So that we can do a factoring here and make this perfect square binomial, because this, trinomial, this is a perfect square trinomial. And how do we find that? Well, we can do sums and products to solve this quadratic normally, but I'm just going to give it to you in this case. This quadratic is the same thing as x plus 2 squared. You see, we used this strategy to find the term that we needed to add here. We added and subtracted it, and now we replace this perfect square trinomial with the binomial squared. And then we can write the yx here, y equals, and whatever's outside we just add together. So plus 7 minus 4 is just plus 3. And this way we have our function in vertex form. You see? Vertex form. And the only thing that you're going to see is different is this subtraction sign, and that's actually very important and very confusing. But anyway, we know we have the vertex form because we have a binomial here, squared plus something outside, okay? Now, how do we take this and use it to graph our function? Because in the end, we're wanting to graph this from the function and by finding our vertex, okay? So then we need to come back to that function, to that formula, and what we know based on this formula is that our vertex is at the coordinate h, k. This is the vertex based on this formula, okay? Knowing that, we need to find the h and k in our quadratic, in our vertex form quadratic. So, first we can identify that our k here, the number that's being added outside, is 3. So we already know that the coordinate of our vertex is, the y coordinate is 3, okay? Because we know the right coordinate is the y coordinate, okay? So this number outside gives us the y coordinate. But now we need to find the x coordinate. And for that, we need to think a little bit, because the formula says that x minus h is inside of this, right? But here what we have inside our binomial that is being squared is x plus 2. And so you can't just say h is 2 because it's not totally correspondent. For you to actually find your h in this case, you need to rewrite this as a subtraction. So this inside this binomial, inside this parenthesis, can be rewritten as x minus, x minus -2, correct? This is another way to say x plus 2. So we rewrite this, so now it's exactly the same as our piece inside the parenthesis in the vertex form. So now we know that x minus -2 is what's inside here. So what's actually our h is the -2, not +2, which I know may be kind of confusing at first, but in the end you need to make this into that formula specifically. So let me rewrite it like fully to make it more clear. Where's my paper? Shoot. Okay. Rewriting it fully, it will look like y equals x minus -2. It's better to write it like this to make sure. Squared plus 3. This is exactly the same, right, as this other function. I just rewrote the +2 as -, and this places it in the exact vertex form. And so this is our h, this is our k, and this way we create our vertex. And now that we have the vertex of our function, we can come to graph it. So we know that our vertex is at x -2, y 3, so we know that it's at -2, 3, and therefore that is our vertex. And then, I mean, this wouldn't be all probably to graph your function, but it's, once you get used to all the strategy, it can be very useful, especially if you can't factor this and you might get lost with the quadratic formula. Very useful, okay? And here, of course, the process is not complete because it's important if you had the intercepts of your function, of the y-intercept, I mean, and also maybe the axis of symmetry specifically. But those we went over in our last video. Also, whether it goes up and down depends on your a term. We also went over that in Hugo's video. So in this case, our a is positive, so this function will be drawn upwards, something like this. And here, if you do this right, you can already probably get most of the points in your question. And yes, that is it with completing the square. Okay, if you have any questions, you can drop me an email, okay, or write something in the comments. But yes, hope you enjoyed. Thank you very much.